So let's do a 1-minute intro, and then I can paste the questions.
All right. Do I just introduce myself kind of thing?
Yeah.
Cool. I have about 2.5 years experience. Haven't done a lot of interview prep, and I want to get back into applying to jobs. So I want to see where I stand at the moment.
Okay. Okay. So the first question we're going to have here is you're going to be given an array of numbers. And I'm looking for triplets where I is less than j is less than k with indexes, and array of I equals 2 times array of j, and array of k equals 2 times array of j. So as an example, let's say we take 8, 8 like this, 4, 8, 8. So in this case, there are going to be 4 triplets. So this is basically, and I just need you to return to me like how many there are, but in this case, by index, that'll be like 0 to 3, 0 to 4, 1 to 3, and 1 to 4. And let me know if you have any questions or anything. Yeah.
Sure. So are these going to be positive numbers? Can they be zeros or negative numbers?
Oh yeah, it can be any number.
Cool. So we're looking for some sort of number where to the left of it is the double of that, and to the right of it is double of that. To sort of restate that. Yeah. I'm thinking what I'm going to do is, or well, let me see if there's more edge cases here. If there's 0, then we want to look for zeros around it. If it's a negative, we have to account for that. But I don't know. I think I just need 3-ish pointers here. The first one, well, brute force would be 3 pointers, where I would loop through each of them, and that would be n cubed. If I were to, is there a way to make that more efficient? I could probably store, when I pass through each index, half of the number I see. And so if I encounter that to the right, I can store like, okay, I've seen to the left of it is a double. I've hit a number where it's not double. And then to the right of it, I can say, if I see it in that left one, or if I see the half number in the left, then I know that I found a triplet. So to describe that in like written out text instead of me just saying it verbally, I would probably be looking for, I would have one sort of hash map that stores halves to the left, which store how many times a given number has appeared to the left. Then I'd have another hash map, which is like pairs seen so far, which is I'm going to say that's the number of basically times that I've seen, or for the given number, if I've seen half of it in this halves to the left, then I would store the count of that here. So this would be like my j indexes, and it would be the count of them. And then if I'm moving through and I see like pairs seen so far is half of the number I'm currently looking at, I would add that to my final count. How's that sound?
So just to clarify this, so I get the first one. So the second one, pairs seen so far. So you have a j and a count. Okay, so I think I see what you're saying. So basically you're saying like you're going to store the number and then like pairs that you have with this number. So for example, when I get to, let's say when I get to here, or yeah, can you just walk through this example with these maps, like do a dry run with these maps, and so I could visualize it better? I think I understand but we can just walk through it because it shouldn't take very long anyway.
Sure. So we have 8, 8, 4, 8, 8. In the first hash map, I'll call that hash 1. Or sorry, let's say that our first pointer is on the first 8. So I equals 0. Then we're going to have in the first hash map, okay, basically 8 was seen once. Then we're going to go to the second, and there's no halves that we've seen so far, so that doesn't have anything. Then we go to the second index, so we'll have 8, 2. Then we'll go to the third index. We'll store in the first hash map 8, 2, and 4, 1. And then in the second hash map, we will store 4, 2, because there's 2 copies that have the 8 to the left of this 4.
Okay.
Then we're going to have 8, 3, 4, 1. And so this is on index 3. Because this 8, or sorry, because we have 4, 2 in our pair seen so far, we know that this is a completed pair, so we can add the 8. But I guess if I were to, no, that's fine. If I was thinking of, if I encountered another 4, I would have to up this number, but that should still be fine because that 4 would be to the right of all the 8s we've seen so far, which is stored all the 8s seen that were to the left of this 4. So I would end up with 8, 3, 4, 1 in my first hash map and 4, 2. And then on the last, or in my count at this point would be 2. And then on the last one, it would be pretty much the same. So we'd have I equals 4, 8 equals 4, 4 is still 2 in the second hash map, and we would get that to 4. Does that make sense?
Yeah, I think that makes sense. And yeah, I think like you're saying, even if you have like, if you encounter more 4s later, I think your code will handle that, but we can look into that later. Okay, yeah, I think we're good. So what's the time and space complexity of this approach?
Like big O stuff, this is only looping through the array once and adding it to different hash maps. Hash lookups should be pretty quick on the scale of O to 1 if the hash function is good. So I'd say this is O(n).
Okay, so O(n) time, and what about space?
Theoretically, if all the numbers are different, we would store n entries in each hash map, so about O(n).
Yep, okay, makes sense. Yeah, you can feel free to code it.
Okay. What am I going to call this? Triplets, nums, set up both my things for num in nums. First, we want to check, do we care about doing any checks before we add it to here? I don't think so. Can I use default dict in here?
Yeah.
Collection. Man, I can't type today. Okay, so for each number, copies to the left, num, we're going to increase by 1. If num, you have to be even, I guess. I'm just going to do num integer divided by 2, or divided by 2. This will be a float if it's odd, I guess. So maybe there's some efficiency for not checking this if it's odd, but I'm not going to think about that right now. And What you were saying? Sorry, I cut you off.
No, I think what you're saying makes sense. Yeah, you have to be even, I think.
So if num divided by 2 is in pairs seen so far, we need a final count. Count plus equals not 1, but num divided by 2. Whatever. Okay. And then I need to handle adding it to this middle one. I add it to the middle one. Oh no, this is where I add it to the middle one. Oops. If num divided by 2 is in copies to the left. Wait a second. No, num in this case is going to be the middle index, which is j. So if num times 2 is in copies to the left, then copies to the left of num is going to be increased by 1. So we're going to say, first off, add it to this hash map. So we have another 8 in this case. Next, if this is something like a 4, we're going to check if 4 times 2, 8, is in copies to the left. And if so, we're going to add, not 1, but we want to add the number of copies to the left in this case. Do we want to add it, or do we want to just set it? I think we want to just set it. If we encounter a 4 later, we don't want to double. Do we want to double? This is just the array of triplets. So we're not dealing with, if there's a 4 to the left, like there's a 4 here and a 4 here, we would have double the number of combinations. So I want to add the number of copies to the left of the number that we're looking at currently, or the number times 2 that we're looking at currently, 2 pairs seem so far of the number. And then if the number we're looking at divided by 2 is in the pairs seen so far, we add the combinations to count. And we would return count. Let me walk through this to make sure I haven't made any dumb mistakes.
Sure.
First off, we have an 8. If I was to walk through the, oh yeah?
No, you can go.
That's like, okay. I saw 8, 8, 4, 8, 8 is the walkthrough I'm going to do. We're going to add copies to the left of 8 is 1. This is false. This is false. I guess I don't need the in statement because we have a default dict. It's just going to default to 0, and we can add 0 to both of these. So I can probably get rid of these. So copies to the left is going to increase by 1 for the 8 index. Then pairs seen so far of 8 is going to increase by the number left of 16. There are none. And then count is going to increase by the pairs seen so far of 4. We've seen no 4s, or we've seen no 4s with 8s to the left. So we'll end up with 8 is 1. Then we're going to have the same thing. 8 is 2. Then we're going to see the 4. 4 is going to be 1 for the first hash. 4 is going to increase by the number of copies to the left. Num times 2 of 4, which is going to be 2 copies of the 8. So 4 is going to have an index of 2. And then there's no 2s to the left, which makes sense. There's no copies of pairs. That would be 4, 2, 4. So to end that, then we'll have an 8. This will go to 3. This won't change because there's no 16s. And 8 divided by 2 is 4. We're going to add 2 to the count, and we're going to add another 2 to the count. Okay. That'll make 4, which I believe is the answer there. Yeah. I think I'm happy with that walkthrough.
Okay. Do you want to write some? Do you want to write some test cases?
Yeah. let's try this. Print triplets 8, 8, 4, 8, 8. That should print out 4. What are some good other test cases? Let's try and include something with 3 zeros in it. That should make a triplet. Let's try something with 2 copies of 4 in it so that they overlap. And let's try also one with an 8 in the middle. And then we'll try one with negative numbers because I'm feeling spicy. So -2, 4, -2, I think is a pair. No, it would be -4. We're not scoring things here. Okay. My gut says this should be 4. This should be 1. This, I guess I can write this down here so I don't have to memorize that. This will be 1. This is 4 for the first 4 and 4 for the second 4, so 8. This will be 1, 2, 5 for the first 4, 5 for the second 4, so 10. And then this will be 1. Let's try this.
Sure.
Button just work. So I got 10 for the first one. That's not right.
You
and then,
did not get 10 for the first one. Oh, you mean the second one?
The second one, my bad.
Yeah.
Misspeak.
Yeah.
Before I investigate that, I want to check out this to see if this should actually be 12. I'm seeing 2 8s, 4, 8, 8, 8. So that should be 3. Okay, so there's actually 6 for each 4. Mm-hmm. There's the first 8 with the 3 8s following, the second 8 with the 3 following, and then the mirrored version. So this should actually be 12. So my coder's right there. The zeros broke it though, which is interesting. Probably because I'm defaulting things to 0, and so it thinks zeros are in there. Weirdly, maybe. So we have 0, or copies to the left of 0 is 1. Pairs seen so far of 0 is going to be, it's because I'm doing these in order. And so it's counting the 0 we just scanned as being double the 0 that we just scanned, and then adding it. So it's treating the first 0 as its own triplicate pair. So we want to add it to the left. I think we want to do these in the reverse order. So we want to, if we look at a number, first say, does this complete a triplicate pair? If so, we'll add it. Then we want to see, is this the second part of a string? And we'll add, or a second part of a pair, we'll add that. And then we'll do the copies to the left. Does that make sense? 0 is going to add nothing, add nothing, add nothing. Pairs seen so far is going to have 0, or is going to have 0 in it, the second number. And then, yeah, I'm going to try and run this.
Sure. I think you can try again, because there's some weird, if you just run again, that weird stuff should go away. I've seen this happen a few times.
Mm-hmm. And I just realized I missed this 0-1 discrepancy. There's something I did here wrong, probably.
You missed the what, sorry?
The 0-1 discrepancy, I expected it. Oh, wait. Yeah, so this is giving me 0 triplicates for this one. What did I do wrong here? Pairs seen so far, -2 divided by 2 is -1, which is 5.
Oh, you're getting 0 there.
Yeah.
I think that is actually correct. Your test case was just you were not counting it wrong. So like there is no, like, what pair do you see here?
-2, -4, -2.
So that's not a triplet because it needs a double going out.
So -2 doubled should be -4, right?
Yes, but the middle one should be the half, right?
Oops.
So if you swap, so I think it's just your test case.
Yeah, thank you so much for that.
Yeah.
That saves me my brain spiraling. Perfect.
Okay.
Okay. Cool. I think I'm complete then, unless you have more questions on that one.
No, I think I'm pretty happy with that. So let's move on.
Cool.
Let's see what we are on time. Okay, so let me write something here. Okay, so for the next question, you're given the root of a binary tree and a start node, and the tree is infected at the start node at time 0. And the infection spreads at 1 unit of time per edge. And I want to know how long does this tree take to get infected. So for example, let's say we have a tree like, so we have a tree like this. 3, 4. Let's move this over here. This. Okay, so let's say we have this tree, and the start node is here. So this will take, let's see, 1, 2, 3, 4 seconds, or 4 units of time to get infected. And yeah, let me know if you have any questions.
Okay. Let's think for a second. So we want to, the start node is always going to be on one side of the tree. I'm thinking, my first thought is there any way that I can just do this by calculating the length of both sides? This isn't a balanced binary tree though, so we could have like this be the infected one right here. And then it would have to spread down and then spread all the way around also. So I don't think I can do anything by just calculating the length of both sides. I can calculate the infected node has to be on one side or the other. Well, I'm going to take a step back. Am I guaranteed to have at least one node in this tree? Could there be no nodes?
Yes. So let's say you're guaranteed to have a node, and the start node is guaranteed to exist in the tree.
Okay. And it's a tree. It's not like a connected graph or something where there's a node between 10 and 4.
No, so there's a tree with a root, and you have tree can have left and right child. It's a binary tree, normal binary tree.
Cool. So I think I want to store at the root the length of both edges, or I want probably the length of both edges for each node. And then when I find the infected node, I want to, this isn't a binary trees don't have parent links probably, or as far as I remember. So I'm not going to say I can just trace up to the parent. That would be nice though.
That's correct, yes. You can only go down to children.
So I feel like I'm doing some form of a traversal through this tree. Whenever I hit or in the traversal of the tree, I'm going to store the length of both branches. Whenever I hit the infected, I want to see if can I just say that it's the max between the length to the left of the node, or sorry, the distance to the infected node, I'm pretty sure for any node above it is the length of the tree to the side that doesn't have the infected node plus the length to the infected node on the side that does have it. Maybe I can traverse through the tree, keeping track of the lengths of both sides and returning also for each node the length, if we're going up, to the infected node. Okay. I think those are my inklings of a plan.
So you said basically like what, like how do you calculate the length? You said you calculate like the length of the longest thing on the left plus the length of the node or something, or can you write down like exactly what you're gonna do?
Sure. So I'm thinking I'm going to do like a DFS style traversal.
Mm-hmm.
And then when I'm at each leaf node, I'm going to increment the like length I've seen. Or sorry, let's say I'm at node before leaf. I can record that the length below it is 1 by returning 1 from the leaf node itself. And then on the one above this node before leaf, I would return 1 from this. So I have the length on each side of the tree. But I think I'm also going to return, if I've seen the infected node, the distance to the infected node. So let's say this is the infected node. When I'm at 1, the number I want to get from the right side edge is going to be a distance of 2, because that's the height of the tree to the right. And then I also want to get a distance of 1, because that's the distance from this node to the infected node. And then for nodes that don't have the infected node in their path, I would probably have like the equivalent of 2 and null or something, or something to denote that this is not present. Maybe I can just put a really big number, like float in for something.
Okay, so basically, just to double check if I'm understanding you correctly, so for every node you're gonna have 2 values. You're gonna have the node, like the distance to the root, and the distance to the infected node if it is in the path. Is that correct?
I think I'm not going to have the distance to the root. I'm going to have the distance from the bottom to the current node.
From the bottom to the current node. And how does that help you?
If I'm at the top node, I have the distance to 5, which would be 2. I can add 1 to that, and I know that it has to transfer through all of that distance because the infected node is not on this side. Then I also have to transfer through the length on the right side minus the distance to the infected node. Because the infected node because the infected node might be here and it would have to transfer up and then down. Mm-hmm. This might not work. I still feel like I need some sort of traversal through this.
Yeah. So basically, like, it's hard to know if the infected node is on the path because it might not be on a direct path, but it might be on like some adjacent path, right? Like, for example, let's say we have a node here and a node here. Infected might be here. Or imagine this is some super long tree, right? With some like leaf, or with some like node, and then the infected node is like here, but then there's also like a node here. And so they're very close to each other, but they're not on the same path and things like that. So there's a lot of like edge cases here. So instead, can you think of the problem? So basically, like, so the problem with a tree, right, is you can't traverse up. Like, so let's say you could traverse up. How would you solve the problem if you could traverse up?
I would traverse up to the. I was going to say I would traverse up to the root and then calculate the length on the opposite side as one number, but then I also have to do that for every node on the path to the root, and then get the maximum of all of those. So if this one was infected, I would need to know at the 3 the distance of this side, which is 2, 10, 3. So there needs to be infected 2 nodes. So maybe I want to store at each node the distance to the infected. Can I do that somehow? Mm-hmm. I can calculate if I see the infected node, when I back propagate up, I can the distance from, say, this 3 to the infected node, which would be 1. And if I didn't see the infected node, I can the length of the subtree, and then I would add the length of the subtree plus the distance to the infected node, or I would get the max of it. So for this 3, the number I want to care about is that there's a distance of 3 that the infected node has to cover, the 3 of the 10 to the 2. Then
what about like so basically what I was saying is like, what about if the infected node is not a direct path but it's very close, right? So imagine you have some long tree, and then like in like this case that I showed before, right, where this is infected. Well, 1 is only 2 away, but how do you know that? Like, how do you cover these cases where you're still getting the distance from other nodes to the infected node, even if they're not on the same path? Because basically it's like, if you can just find the this is basically asking how long does it take for the furthest node to be infected, right?
Mm-hmm.
So yeah, so is there any way, like, if we can traverse in every direction, we can get that for every node, and not be limited by the tree, like the tree traversal path, because it might not be on a direct 1 3 10 2, but you can traverse, like, you can still get to every node from the infected node, essentially. So is there any way we could do that?
Yeah, if there were connections between everything, you could do like a BFS flood fill algorithm.
Exactly. Yeah. So in a tree, there aren't connections between everything. So can we modify our data structure so everything is connected, and then we can do a flood fill algorithm? Yeah, basically.
Okay, so we just store the parent on each node. I guess we could do that.
Okay.
Is that, for a second I was going to say, am I allowed to do that? But it sounds like I just can't, I guess.
Well, you can't store it. So if you're given a tree of this format, right? Let's say you have a tree, and the tree has like a value, a left and a right child. You can't store it directly in data structure, but you're free to add whatever you want, right? So
maybe when it goes, okay, maybe I can, when I add things to my queue for my BFS traversal, I can add the parent node as well, and I can maybe leverage that to go up the tree for a BFS. But I still need to find the path to the start node to start that even.
Right.
Now I'm thinking if I could do some sort of. No, I was thinking if I could do like a priority queue or something to store the length to the infected node, but I wouldn't know when I added things to the queue what the length to the infected node is. I only know it once I've seen it infected.
As long as you know where the start node is, like as long as you have access to it and you can travel in every direction, why would you need a priority queue? Like every edge is length 1.
Yeah, no, I don't think I would. I think my current plan is to do a BFS traversal, storing, I guess, the level down of the tree that I'm at. When I hit the infected node, I know I have to go at least that many levels up, and I would complete the BFS. Or sorry, I have to go at least that many levels up to get the BFS result on the left side, or the side that the infected node isn't on. And I'd have to get also the BFS distance on the side that the node currently is on. So for each node, as I do the BFS, I can store the length. Or no, I think I'm going to return. I can get the level that the infected node is at. I need to get the distance up though and then down. I'm trying to see what my insertion case is.
It's going to be kind of difficult to do it all in one. So can you like break it down to multiple stages? Like essentially in the first one you find the infected node and you also somehow store parents so then you can traverse up, and in the second stage you do the BFS from the start node. And then that way it'll be like, I don't think you can do it all in one, like in one BFS. Maybe, but I doubt it. So yeah, it would be easier if you could like break it down.
Sure. Then in that case, I could do one BFS to store pairs of like node and parent as like tuples or something. Mm-hmm. And then I could, or sorry, doesn't matter if it's BFS or DFS, but one traversal to do that. Then the next one I do a flood fill basically, starting from the infected node, going to parents and then scanning children.
Mm-hmm.
Yeah, that seems like a solid plan. Should I write some pseudocode for that?
If you want.
Sure. So I would have something along the lines of a tree node that has a left, right value. I'd have BFS1, which is going to iterate through. So for node in queue. And we want to store basically, let's do a hash map of node to level, or no, node to parent is what we were saying. So I could do the actual flood fill. Then for node in queue, I'm going to do hash map node. I have to store the parent somewhere. I don't know. Hash map node dot left equals node. Same thing with node dot right. Q append node dot left, and we're going to do the same with node dot right. This will be a while loop. While length of that or whatever. So that's my first loop through. I guess this doesn't need to be a BFS, but I have a queue there because that's the data structure I chose. But yeah, now I need to do queue equals my infected node. Let's call the parameter infect, or while length, we'll store a distance, while length of queue, we're gonna get a node from the queue, up, and we're gonna add to the queue node dot left, node dot right, and hash map node. Let's think. I also need to store the height, or the levels of each of those. So those will probably be tuples of this node level. Yeah. So it'll be 3 copies of these tuples with level +1. I'd probably want like a max dist. And I will update max dist to level +1. Yeah. I also need a scene array thing too. Where I'm going to add that, but I guess I don't need it for the first one. Yeah. That was a lot of just scrambling. You were saying something?
Yeah. So you have a level and you have a dist and a max dist. So what's the level and what's the dist, and is there a difference?
Level is going to be the distance to the node. I don't think I need this up here.
Okay.
I think I got lost in my own naming.
Okay. Yeah, I think this looks good. I think you can code it, or you can write some more stuff, up to you. And so last question. So what's the time and space complexity of this approach?
For the first loop through, I'm visiting each node once. So that's O of n, and it uses a hash map that's going to store each node. So that's going to be also on the scale of O to n if it was like just a single line tree. Then I'm going to have an O of n space usage for my queue potentially as I loop through each node, which is also going to be O of n. So I think this is O of n. I don't think this is log n though, because I'm looking at all the nodes.
Okay. And the space?
O of n is going to be, or each node is going to be stored in the hash map potentially, but I don't think I do anything exponentially greater than that.
Okay. Yeah, I think that makes sense. Yeah, I mean, I don't think you can have a login because you still need to look through the nodes.
Yeah.
So, yeah. Okay. You can code it.
Okay. So, let's say that my tree. Would you mind if I just had my tree nodes be? No, I don't want to just have a bazillion tuples. Let me try and
Let me
remember.
just paste the tree for you to save time.
That'll save me time because I forgot how to write it.
Definitely good to review, but yeah.
Yes, definitely. Def infect time is going to take in a root node and an infected node. So what do I have here? I'm going to do the BFS traversal. Then I'm going to do another BFS traversal. Okay. Parents equals this. Q slash stack equals this. I guess. Can I import DQ?
Yeah.
DQ is not the Q. It's just it has the append left and append right. I need to review that too, I guess. Okay. While length of Q. This is going to start with root. Parents. Sorry. If root.left is not null, parents root.left equals, stop using root, equals q.pop left, I believe.
Yeah, I think that's right.
Okay. Node.left, parents node, copy this for the right. Then I don't need a scene thing here because this is directed, so I'm never going to see the same node again. So that should loop through and populate the parents. I need to add the children nodes. Do the q dot append. I imported DQ and I need to actually use it.
Yeah.
Okay. So that'll add the left and right nodes. Then I'll have the parent thing. Next up, I have. Do I need scene anymore? No. Because as I traverse through this, no, I don't want to go back down the path I just went. So yeah, scene is going to be this. Q equals DQ infected max dist equals 1. Around the 0. If I start with I only have the 2, which is the infected node, is 0 nodes infected, and then 1 node if I have to go to the parent.
Oh, is that a question?
Yeah, sorry.
So
Yeah,
I didn't really
there's
get what you said. Like you said, you start at a node and then you 1 if you go to the parent. Like that's your question.
My bad. If the root node is the infected node and it's the only node, the infected time is 0, right?
Yeah.
And then if there's 1 node connected to it, the infected time would be 1. Okay. So the max dist is 0, while length of Q. I want to do these as tuples. Node comma dist equals Q dot pop left. Q. Sorry. If node dot left not in scene and node dot left is not none. We'll want to add it to the queue. Append node dot left comma dist plus 1. Is append wrong here? Why is this upset with me? Part of type tuple unknown int.
I'm not sure.
I'm gonna come back to that. Let me just finish skeletoning this out. I don't need a none check on the parent. Scene. This can be a set, but I'll change that later. Okay, slammed a bunch of code down. Let's see if this makes sense.
Sure.
Well, this error I said I would come back to is still here. Argument type tuple unknown int cannot be assigned to parameter __ x of type tuple. Is it like a pen to write or something?
No, I think it is append.
Okay.
I think let's just leave that unless you know,
Yeah,
and then look at everything else and make sure it's good.
yeah. Okay. So let me do this example up here. Let me simplify this a bit, probably.
Mm-hmm.
We'll just have the 3 be infected. So we're going to go through. We're going to set up the queue with the root, which is the top one. We're going to pop it from the queue. So the queue is empty. We're going to add the left node if it exists, which it does, and add it to the queue. We're going to add the right node, and we're going to add it to the queue. We're going to keep going through the queue, adding left and right nodes until we have this parents dictionary set up, where parents of a node is the node's parent. Okay. Then we get down to here. We have this scene array, and we need or scene hash map, and we need that because we are traversing up and down, and we don't want to retread the path that we traversed. We don't need that here because we're always going down the tree. We start the queue with the infected node and 0, and we start a distance of 0. We pop from it. If the distance is greater than max distance, we update it. If we've not seen the node to the left, because that none, we're going to append it to the queue and mark it as seen. Do the same with the right node, do the same with the parent node. And we're always adding distance plus 1. And then we'll end up updating it on the end when we finally scan that node and see that there's no nodes there. And then we return max dist. I think this works. That wasn't my best walkthrough.
Okay, let me ask you a couple questions because we have like a couple minutes left. So if we're at a node that has no parent, what happens? Is it still fine?
If the node doesn't have a parent, that means it's... If the node doesn't have a parent, that means it's the root node. Mm-hmm. So we still probably... No, we need to check that parent's node is not none.
Okay. Yeah, I wasn't sure because I think
actually... Oh, yeah, you go.
Yeah. I was going to say, I think if it's none, I mean, I don't know how it works in Python, but if it's none and it wouldn't be in scene anyway, right?
Yeah. I just want to make sure that we like actually put the root node in the queue. And that'll be happening on the child of the root node. So yeah, I think this will be fine.
Agreed. So you're adding nodes to the visited set as well as you put them in the queue, but you forgot one thing here. Can you think of what that is? Like, look through this code, and you're missing something with the visited set.
So I'm adding them when I do this first, but I don't add the original node into the scene set. Yeah.
Okay, and then as far as I know, I think a key and a value in a Python map can be a tree node. I think that's fine. So I think your code does work there, right? Because I think keys are hashable and values are hashable. So
yeah, tuples are hashable, if that's what you're referring to.
No. I meant like your parent is like a node and a node, right? Key value is a node and a node, which I think is fine.
Oh, yeah, I think that's fine.
Yeah. I don't know what this error is, honestly. I don't know what the literal 0 is. You can look at that in your own time. But yeah, I don't think we have time to write test cases. Also, for this one's kind of a pain. So we can just call it here, and we're at like 50 minutes.
Okay.
So how do you think you did? What do you think you did well? What do you think you can improve in?
I think I need to improve a lot on like actually doing some of these more in-depth programming ones that aren't like 10 lines of code. And I also think I need to be more aware that I can traverse things more than once. I don't have to like do everything one shot. I need a lot more practice with probably different data structures and algorithms because we got to the tree stuff and I didn't remember how to write class tree node.
Mm-hmm.
I need to look into the DQ API just to make sure that I have that memorized.
Mm-hmm.
Um, but in particular, I think I just need more practice doing some of these programming tasks where they don't give you a lot of a shell and the non simple iterate through once ones. I don't know.
Yeah. Yeah.
That's
So I
a
do.
big practice. Yeah.
Yeah. So I do agree with pretty much all that. So I think for the first one, I think it's pretty simple problem, and it was a good like have you done any leak code at all? Like, can you do some basic stuff? Like, I think it's pretty straightforward, and you pretty much did super well, right? So you realize like, okay, I can brute force 3 pointers, or I can have these two hash maps. This does work. I think a simpler solution would be you keep track of numbers to the left and the right, and then you wouldn't have to do this pairs thing because it's a little bit more confusing. But either one, totally fine. And you basically wrote down some like pseudocode, I think, or maybe didn't. I don't remember. But yeah, basically it was like you kind of knew what you need to do. You did in your code miss some like if you weren't able to run your code, it was technically incorrect. But
Mm.
you did a really good job of testing. You had a lot of like tests that did different things, and then your tests figured out like your mistake. And then once you found your mistake, you're able to correct it basically instantly. So I would say on the first problem, if I just gave you the first problem as like a text screen, I would say this would be like an easy pass. Um, like a solid pass. I think areas you can improve on is obviously coding and like not have the mistake to begin with, but I think it was good enough. And then for the second one, yeah, so I think you tried to, and almost all people try to do this. They try to figure out some like one pass approach of like how do I maintain something, and then like the biggest number is like the distance, but then I have to point out all these edge cases. Well, what if the node is here? What if it's here? It doesn't like your thing doesn't work here, and so on. And I kind of hinted at like, well, like so a tree you can't go up to the parent, but what if you could? And so you definitely need to and this is pretty common, need to like think a little bit more broadly, and like you can do whatever you want, right? Just because you're given a tree doesn't mean you can like not turn it into a linked list or whatever you need for the problem. And you definitely don't have to try to like one shot stuff. So I think even when I gave you the oh yeah, so you can go up to the parent, you were still trying to like one shot it, and it was probably not going to work. I mean, maybe you could think about it in your own time, but yeah, like, realistically it's depending on where the nodes are in the structure of the tree, like you can't really get everything you need in one pass. Um, and so if you just think a little bit more broadly, you're like, well, the problem is I can't move up the tree. But if I just had like an undirected graph and I got asked this question, then this is like a really easy problem, right? Just BFS from the node, and then I just get an answer. So the two common solutions are either this parent thing or just turn this into an undirected graph, and either one's totally fine. So definitely try to think outside the box a little bit, and like uh basically work on your problem solving a little bit. And then let me see if I had any other. So you also did a good job of once you did figure out what to do, you did a good job of like writing down like, I mean, this is like personal preference. You wrote down some like pseudocode. This was basically code, but totally fine. And then when you were writing your code, like it was pretty clear to you what you needed to do. Uh, but then definitely during coding, like if you don't know how to write a class in an interview and this is your chosen language, then it's like pretty bad, right? So definitely be
Mm.
very familiar with like the fundamental stuff. I mean, a lot of people pick Python for coding interviews, and their main language is something else. Like from you writing this stuff, I might think you like coding JavaScript or something. Uh, I guess what do you normally code in?
I normally code in Python. I just never have to write classes.
Okay, yeah, yeah. So and that's also fair. So you might code in Python, but you might not use these things on a daily basis. Like how often do you need to use a DQ, or whatever, or
Yeah.
classes? Yeah, if most stuff is functional. So definitely be familiar with like DQ, default dict, whatever you choose to use. Like super familiar with that stuff, because it's definitely not good if you can't do. I think I actually had an interview where I had to do some object oriented stuff, and they made me do it in Python, and I didn't remember how to do like inheritance. Like I was like, yeah,
Mm.
I know the general idea, but I don't know the syntax for this stuff. And I basically failed because of that, because I didn't know like, and it's pretty like basic syntax. Like if you have one class and you inherit from another class, like how do you do that? So definitely be familiar with like the basics of the language, have multiple classes, have like good code quality, all that stuff. And then let's see. Yeah, and then this stuff too, right? So you get this error. Like I don't know what it is because I don't code in
Mhm.
Python. But if you do pick to do stuff in Python and you get errors and you can't figure out like what it is, that definitely doesn't look great, right?
Yeah.
So I think I'm honestly not sure what this is. I would have just stored numbers in the hash map and stuff and in the queue. But I think it just like doesn't know the type or something. It says tuple unknown.
Yeah, I
So it's something
think
like
like if
that.
I do this, it might just be fine. I think it just doesn't like me putting it in there for some reason. It thinks it's parameters.
Yeah, like the pen thing is definitely right. So yeah, so
Uh,
unknown cannot be tuple missing incorrect type. Okay, it looks like you are still getting an error, but yeah, so you can look into that.
yeah, I'll
Um,
figure that out later.
yeah, but yeah, so definitely you want to be familiar with like the language, and then yeah, obviously like I had to give you a lot of hints here. So definitely like get better at that, and then like I think your coding was pretty good. You did have some slight bugs, but you fixed almost all. Like, so the parents thing happened to work. That would have been a good one to check for, because like I don't like I wasn't sure if like did it work because you knew it would work, or did it work because you just got lucky, right? Like I wasn't sure about that one. And then yeah, the visited set in the beginning, but for the most part, I think it was pretty good. So I would say for the second problem, I would give you like a fail because yeah, I just had to give you a lot of hints and we kind of like ran out of time. I think the areas you do well in is like communication. It seems like your DSA knowledge is like okay. But then yeah, basically like try to problem solve tougher problems and then just do more problems and be able to like code things well. And then yeah, I think your testing is good. So definitely yeah, do like more problems, more complex problems. And then I think you basically pointed out like most of the areas where you struggled. Um, and and then also obviously speed, right? So depending on like how long you have, because I think for this level problem, I would expect you to have both problems done with a few test cases because like the first one realistically is like pretty easy. The second one
Yeah.
also once you know what to do is not that hard. So and I think we did like 50 minutes and you I mean you mostly finished, but yeah. So I'd say this would be like a right on the borderline for a tech screen of like a pass or not pass. I'd probably say not pass just to be conservative. But definitely, like I think if you work on this stuff a little bit more, and then yeah, the algorithms you mentioned you just started doing, like usually when people mention they just started doing stuff and they give them a problem in it, like they're not familiar enough in it to do well. So
Yeah.
I'm like, let's just not do that. Um, and
That's
some,
very fair.
but you do some
Mhm.
problems in it, and then you can definitely do fine. So like my impression after the first problem was like, yeah, honestly, I don't know how much harder of a problem I can give you, and you do well. Like honestly, I thought the second problem might be too easy for you because you just like crushed the first one. So I do that a lot where I'm like, oh, they crushed the first one. Maybe the second one I had lined up is too easy. Let's give them something harder, and then it ends up not being the case. But yeah, in this one, like the second one was definitely not too easy for you. So definitely just do more problems, and then yeah, maybe we can do like a harder level mock where you're like more comfortable in like what you're doing. I think the
Okay.
communication is good and the testing is good though. A lot of people struggle with that. I feel like you were quite good at that. So I don't know if you like practice that or whatever, but those parts are definitely fine.
I think I just talk to myself a lot, so it's not ever been a problem for me.
Yeah, yeah. But for some people, it's a huge problem. They're like, I usually code and don't say words. So then when I code in an interview, I don't say a word either, and then it's like a problem. But yeah, I guess talking to yourself pays off. Yeah.
Yeah. Okay. So I think my plan for here, I'll probably just run through some of the more complex data structure wise neat code problems
Mm-hmm.
to like get more practice with both like some of these more complex things where I'm like, just do the DFS or do the BFS a few times
Mm-hmm.
and try some of the harder data structure ones to just get my foot under myself.
Yeah, so you can learn like union find Dijkstra's like the Kruskal Prince thing you were mentioning. I don't know if you've done DP, look into that. And then also just try to code problems that have a lot of code. So there's like just look at solutions and or problems and the ones that take like 50, 100 lines of code, try to do those and try to write it correctly and write it cleanly. I think that's another thing. It's like just do things that are more complicated that aren't 10 lines of code. Because some things are a complicated algorithm, but once you get like the hint or how it works, it's like 10 lines of code. So that's like another area. So basically the way I try to think of it is like first be able to take a problem and get like a pseudocode or whatever solution very quickly. Once you're very good at that, then try to code cleanly and correctly. And for that, you just need problems that are like, I think this one's a pretty good one because you have to do like a 2 BFSs or something. So try to find problems like that are like decent amount of code, decent amount of places you can screw up. And then try to ideally, when you code, look through your solution afterwards and try to make sure it works with no bugs. Ideally, you might have like a few here or there, but you don't want to, I've seen some people code and they have like 10. So you definitely want to like avoid bugs as much as possible without just running it over and over and over and over and relying on that. But yeah, so once you do that, feel free to book another one. Like once you get a little bit better, and I mean, it takes a while for everyone, so totally fine.
Yeah, I assume this is more of like you said this before, but this is like the tech screen level. I assume like the actual interview level is harder than this, right?
Yeah, so I think the second question is on the easier side of an on-site maybe, but reasonable. The first one I think is like just too easy to ask for an on-site, in my opinion. For like I mean, it depends what level you're going for, but like you said, you have like a couple years of experience. If you're going for like mid-level, like I think it's a little bit too simple to ask for an on-site. So yeah. So
Okay.
maybe it would be like 2 questions like the second one. Seems around correct.
Cool.
Okay.
Well, this has been sobering. I really appreciate it.
Yeah, no problem. Okay. Catch you later.
Yeah, see ya.
See ya.